Hello to all our chemistry students. How are you doing? I'm here in the fume hood at school, and it's not always you get a chance to see some of the chemicals that you've learnt about in your course. You've learned about polymerisation, right? Taking small units and creating a very long chain organic molecule. Well, how do you do that? One of the ways you can do that is with mixing two chemicals that are primed to undergo a condensation polymerisation. That is, we're going to knock out and eliminate one part of the molecule on one of the long chains, and in eliminating join with another molecule and create this interesting cross-linked plastic. In this beaker we've got 1,6-diaminohexane, so that's here, and over here I've also got a little molecule called Sebacoyl chloride. You can look up the names of both of those two. If you combine these two, well, let's find out what happens. What we're going to do is a condensation polymerisation. So I've got not very much, probably about 30 mils of the diaminohexane. So that's going to be our little base molecule here. I'm going to try to get equal volume of the Sebacoyl chloride here, and I'm going to run it not straight into the jar, but I'm going to run it down the side of the beaker. I'll do that so you can see. Just gently. I've got to be more careful than I'm being there. And what I want to do is keep on going, being careful not to touch my pipette into the chemical, so I don't want to backfill that hexane into the Sebacoyl bottle. And you can see there's a few things going on at the surface. If you can see what I see from here, it's going a kind of glistening, gooby colour. And what I'm making is an interface. That is a place where the two liquids aren't mixing, they're immiscible, that they are actually forming a nice little line between them. And along the very, very top of where the two chemicals are reacting, our polymerisation is happening right now. Okay, I think I've probably put enough in there that should be equal volumes. And then over here, all right, got myself a pair of tweezers. I'm going to try and drag out from the line between the two, the interface, a polymer. And here we go. And here it comes. Oh, I dropped it. There it is. Look at that nice gooby piece. And that, my friends, is Nylon 66. Nylon 66. See how long we can make it go. Ooh, oh, it's a big one. But it broke in half. Reminds me of pulling pizza. A piece of pizza away from the main pizza pie. All the mozzarella cheese is stretching. There it goes. Look at that. If you get enough of this chemical together, you can actually get it to last up to a stretch of about 1 metre. Enough of this stuff, you can actually make it go for metres and metres. Oh, look at this. Look how big it is. Enormous. And when they make this commercially, obviously they don't have like 50 million people sitting inside next to beakers doing all this. What they would have is a large machine, and they pull out the nylon thread at very high speed out of a machine, and then those threads are quickly washed, because this is actually very acidic, this environment, so I'm not touching it, this chemical. So they wash it, and then those bundles of fibres are woven together into thicker bundles. And then nylon is used for all sorts of things. You know from your course in production of materials, look up what's nylon used for. You want to look in the area of textiles, and especially in the 70s, this stuff was really, really helpful to ladies, because they used it to make a special kind of pantyhose that stayed up really easily on your legs, and they weren't called pantyhose, they were called nylons. Fun facts, make sure you look up prac experiences online to give yourself as much of a visual and an understanding of the prac experiments that you might be assessed on the HSC, because there are a lot of prac questions that come up. You never know which one they're going to pick. Hope you enjoy your nylon. Bye.